Right, just going to do a little YouTube here on the next area in trigonometry, which is to do with this radian measure, and I described that today to Lewis as comparable to miles and kilometres, in that it's just another way of measuring angles. So radians, that's the first thing to perhaps look at here, is when it comes to radians, just another way to measure angles. Now you might say, well, what's the point of that? We've got degrees. I'm happy with that, but radians, apart from being in the course, there is a use to them, and they're perhaps just a little bit more logical than degrees. But we'll look at that. So, but just think of it like miles and kilometres. There's just different methods, different ways of representing angles, like there are different ways of measuring representing lengths. Right. So you've all know that there's a radian option on your calculator. You go in and into settings. If we go into settings, we'll see document settings. Right here, you can change your calculator degrees, radians. So we need to now, once we've done some work on radians, we're going to be doing some work here. We need to be sure what our calculator is in, what mode it's in, because otherwise we'll be getting the incorrect results when we do our calculations. Right, so let's just put this as simply as we can, and I think the textbook does it very well actually. On page 391, a really nice explanation, just a very simple definition, and I'll talk the definition through as I draw a circle. Okay, so simply this. So if that's my radius, I'll just call that R. What 1 radian is, it's the central angle, the angle here at the centre, that gives me an arc here on the circumference, that is the same length as this radius. So if I work out what that radius is there, if I was able to say take that bit of string there and run it along the circumference, let's say it got to about there, so that was my R length there, then that will be 1 radian. So 1 radian, if you can just write this definition down, which is, so I'm sort of plagiarising a little bit from the textbook on page 391. 1 radian is the size of the central angle. I like that word, central angle, the angle at the centre, this one here. The size of the central angle that subtends an arc length equal to the radius. 1 radian is the size of the central angle, this here, that subtends an arc length. So this word subtends, an angle subtends an arc length, and that's it there in yellow. Arc length. So that arc length there, so it's central angle that subtends an arc length equal to the radius. So that's 1 radian there. If obviously as this radius gets larger, the circle gets bigger, so does the arc length, but the angle in here won't change a bit. So by definition, with 2 radians will be 2r. If we start to look at how that would work with some examples, then if I give you, let's say that this is a 2 centimetre radius circle, and the length here is 2 centimetres, then that's 1 radian. But let's say we change that up a little bit now, so that we've got, so I'm just backtracking here, so that's not 2 centimetres but 4 centimetres. Then what would this angle in here be? So if 2 centimetres is 1 radian, then 4 centimeters must be 2 radians, etc. So now if we make that, if we make this, obviously this needs to change as well. So keep that at 2 centimeters, but now we'll wrap it around here so that this here is equal to, let's say, 2.5 radians. Then what would the arc length here be? What would the length of that arc be? If that's 2.5 radians, so 1 radian, so each radian is 2 centimeters. Another radian, that's 2 centimeters, so 2.5 times 2, so this arc length here will be equal to 2 times 2.5, and you can quickly see, it should be 5 centimeters, you can quickly see that the relationship here between the radius and the central angle and the arc length is such that the arc length will be the product of these two here. So we can just write that down as a nice little result. Arc length, which we're going to call L, is equal to the radius times the theta, and it's really important here that we note that theta is in radians. Okay, so that's a really important result. Arc length is equal to r theta, and if we want to put a picture next to that, then that's my r there, that's my theta there, and my arc length is just there. Arc length equals r theta. Excellent. So quick example, here's my circle, they're getting worse, that's 4 centimeters, which of course is that as well, and my radius, my angle here is 1.5 radians, then my arc length is, which is r theta, is 4 times 1.5, which is 6 centimeters. If we've got the angle in, let's say the angle is in, let's say it's in, what am I trying to say? Degrees, so 60 degrees. What's that in terms of radians? Well, we need to work that out now. So if we've got, let's go back up here, if 1 radian gives us an arc length of r, how many radians is it all the way around? So what is the circumference of this circle with radius r? The circumference, so the circumference is 2 pi r. Now 2 pi r is the whole circumference, so that's when you've got the whole arc length, that's the whole circumference. So what would the angle at the centre be? Well, let's work this out. Our arc length is equal to r theta. Our arc length here is 2 pi r. We're trying to find out what the angle is, but r is, radius is r theta, so theta is equal to 2 pi. So 2 pi is my angle right here. So 2 pi radians is equal to 360 degrees. That's a big result. 2 pi radians is equal to 360 degrees. So you can see now the difference here between degrees and radians. Degrees is a, well, it's a bit of an old-fashioned arbitrary figure, 360, whereas 2 pi, it's related to the circumference of a circle, which is a rotation, so it makes sense. So it's radians is more in sync, I suppose, with other elements of a circle, other properties of a circle. So 2 pi radians is 360. So from that, obviously, pi radians is equal to 180 degrees, and we can work out from that what 1 radian is. 1 radian divided by pi, that's 180 over pi degrees, and 1 degree is pi over 180 radians. So they're going to help with conversions, and we'll do an exercise on that. Okay, but if we've got 60 degrees, well, what's that? Down here we're at 60 degrees. 60 degrees is 60 pi over 180, which is, what's that? Pi over 3. So we just do a little calculation down here. So 60 degrees is equal to 60 pi over 180 radians. Remember, I need to change this to radians in order to calculate the arc length. And that's equal to, well, that's, I can go that goes 3, so it's pi over 3. So I can change my arc length here. I need to give you a radius. So now my arc length is equal to r3 times theta pi over 3, which is equal to pi centimeters. That's how we work the arc length out there. Okay, sector area is the last little thing I want to look at here. So the area of a sector, you know what a sector is. Sector is just a piece of pie in a circle. That's a sector. Remember, a segment, while we're talking about it, a segment is, that's the segment there. Whereas this is a sector. So a sector area, this is a sector. So sector area, if we've got this angle in here, theta, and this, and our radius is r, then what's our area going to be? Area bracket sector. Well, what fraction of the circle do we have there? We've got theta over not 360. We're in radians now. We're in radian language. Theta over 2 pi. You can see how this is so much nicer to work with in a second, because the whole area of that circle is pi r squared. Now our pi's are going to cancel, which is brilliant. And this looks like that. Again, theta in radians. There's a little footnote there. So our area of our sector is equal to a half r squared theta, which is a nice little result. Quick example. It's going to be a straightforward one. It's going to have a sector like this. I'm going to have 2 pi on 3 radians here. I'm going to have 6 centimeters here, and I want this area. Area equals, let's use the formula, half times 6 squared times 2 pi on 3. 36 over 2, so that's 18 times 2 pi over 3. I'm just going to do this exact 1 there, 6 there. So we end up with 12 pi centimeters. It's area, so it's centimeters squared. That's an exact value. If we wanted to get it, it's 12 pi. Where is pi? He's there, isn't he? 12 pi. Hit enter. Hit control enter. 37.7 to 3 significant figures. That's to 3 SF. Okay, so that's loads of work to get on with now. I think that brings us up to the end of chapter 11. So tomorrow will be a working lesson. I'd like you tonight to have taken notes from this YouTube, and also perhaps have finished 11J, so that tomorrow in class we can work through the work requirements on 11K and 11L, and then we are finished, and 11M as well. We're finished with trigonometry, and we can move on to the next topic. Alright, have a good night. See you tomorrow.